Hi guys, this is Jonathan from Everybody's Favorite Data Blog, here to walk you through this IPython notebook that we've shared that basically applies independent component analysis to audio clips. Okay, so briefly, there are four essential cells in the notebook. The first one is devoted to taking the audio clips that we start with. The second cell creates random mixtures of the two audio clips. Um, these two mixed signals are going to be the inputs to ICA, which is the third cell here. So the goal here is to basically remix the two mixtures and look for the mixtures to have some nice property. Once you find those mixtures that have the nice properties where the peaks occur, you can construct these new mixtures of the mixed up signals and spit them out. And hopefully what we'll find is that those mixtures are basically the pure signals that we started with. So we can take the dirty or mixed signals, inject them into ICA, and what comes out the other side will be the pure signals that we wanted to begin with. Okay, so let's begin. We're going to take two 5-second recordings. I'm going to start with a little bit of Debussy. Okay, great. So let's check that that worked by plotting the signal. Great, so we got a nice strong signal there. Now we're going to take a second recording. Make sure that you change the name to amplitude 2 so that you don't overwrite the signal we just took.
Another cafe latte? Yeah, you better believe it. Since when are you so trendy? Hey, baby, I set the trends. Who do you think started this whole cafe latte? I don't recall you drinking cafe latte.
Okay, so we've got the two signals. Let's check a plot of the second one too. Okay, great. So they both worked. We've got two separate signals, and these plots are really nice. They demonstrate the basic idea here. Notice that, for instance, when blue has kind of a quiescent period, this is the Seinfeld one, Debussy was alive and well at that time. And likewise, when red has a quiet period, it's often the case that blue does not. So that's the basic gist. If you take a linear combination of the two signals, you end up getting something that's more sort of consistently on. ICA is going to take these mixtures and try to find the linear combinations where you get the quiescent periods reappearing, something that's less consistent, less Gaussian, and those weights hopefully are going to be along these pure signals that we started with. Okay, so that's the idea. We're ready for the second cell where we're going to take random linear combinations. So we're going to generate these new signals that are mixtures. You can feel free to print out this array. You're going to see that it's just a long array of integers. These are amplitudes. Now I'm going to play a mixture for you so you can hear what they sound like.
Since when are you so trendy? Hey, baby, I set the trends. Who do you think started this whole cafe?
Awesome. So that was a mixture of Debussy and Kramer.
Since when are you so trendy? Hey, baby, I set the trends. Who do you think started this whole cafe?
Awesome. So they both are nice mixtures. These are now going to be injected to ICA. So I'm going to run that now. What this function does is it takes as input the amplitude that we're going to put on the first mixture. And then the second amplitude or weight is just going to be a simple function of the past C1. We're going to construct this new signal. And then we are going to print out the kurtosis of the resulting mixture. Okay, so we loop through a bunch of different weights for the first guy, calculate the kurtosis, and then make a plot. And this is what we get. Kurtosis is a measure of non-Gaussianness, so if we plug in the maximum, the value that gave us the maximum kurtosis, we're hoping that that will be one of the pure signals. We're also going to try the minimum, but what you'll see here is that there's two other extrema, and what I've found playing with this is that often one of the pure signals is along the max or min, but the second extremum is along one of these other, one of the other pure signals is usually along one of these others. I think it may be the other maximum in general, but I'm not sure. So maybe one of you can take a look at that for me. Anyway, what we're going to do in the last cell is take a look at the weight that suggested a maximum, construct that signal here, also look at the one that corresponded to the minimum, I guess over here, and split that one out. And then we're going to see if these new remix signals are along the pure directions. Okay.
Since when are you so trendy? Hey, baby, I set the trends. What do you think started this whole...
Wow, it actually worked. So that's awesome. Just Seinfeld.
Since when are you so trendy? Hey, baby.
Okay, and that one didn't work. That was still Debussy and Seinfeld. So what happened was this one was the pure Seinfeld, but this one was not the pure Debussy. Debussy sits along here or here. I'll leave you guys to explore that and figure out if you can find out in general which two peaks are going to correspond to the two solutions. I haven't figured that out yet. That's it though. Very simple. We take some pure signals, mix them up randomly in 10 lines of code, find the directions that maximize the kurtosis or extremize it, construct the mixtures that are suggested by that, and boom, at least one of them was the pure signal.
Hey, baby, I set the trends.
That's awesome. Okay, hope you enjoyed.